As you'll see and kind of get used to in this class, we use units all the time in chemistry. I mean, I basically shouldn't see a number without a unit until the last 2 weeks of school, and I'll expressly tell you this number doesn't get a unit. So everything that we do has units, and a lot of the mathematical techniques that we're going to use are actually driven by units. So understanding units and where they come from is really important for success in chemistry. So in general, we use the SI system of measurements, and that's the Système International, or however the French would say it. And so, for example, we use, we equate a lot of these to like the metric system, right? So the standard unit for length is the meter, okay? And so you saw this table in your textbook, and we have the quantity here is a length, and the unit is the meter, and then the abbreviation is M, the length of the path traveled by light in a vacuum during a time interval of 299,792,458 of a second. Okay, so some of these have sort of funny definitions, and some of them, like the kilogram, is just defined. There's an international prototype that gets stored in a glass vial, and it's under argon, so it can't react with anything, and it's just like a chunk of metal. Okay, so now notice that for mass, we actually use the unit kilogram a lot. While we will end up using grams more than kilograms, but it's important to know that the standard, the base unit, is the kilogram. Okay? Time, seconds, temperature, Kelvin. We're going to talk more about the Kelvin scale much later in the year. And the mole we'll talk about, and then these last two, these are things that you'll cover in physics. Okay? Now, if we take something like the meter, okay, now I could represent vastly different sizes of lengths, right? Like the distance from, or the length from the Earth to the Sun versus the length of, or the width of a human hair, okay? So obviously, we don't want to be using meters for everything, so we use prefixes, okay? And I prefer to keep the prefixes in these exponential factors, and we'll use scientific notation a lot in this class, so keeping things in the exponential factor makes your life a little easier, and plus there are some definite trends here, and not having to write 1 over 1 billionth for a nano, which we'll use, is nice, okay? So there are definitely some ones that I need you to know and be able to use quickly and easily. These are ones that we use a lot in chemistry. Kilo, then the base, centi, milli, micro, nano. These are all things that get used a lot in chemistry. The deca, the hecto, they don't get used quite as often. Not 100% sure why, but in my time in chemistry, I've basically only seen deca used once, and I've never seen deca or hecto used at all. So these are things that that I expect you to be able to know. And if you look, they follow kind of a pattern, right? So 10 to the 3, 10 to the 0, and then if I skip centi, 10 to the minus 3, 10 to the minus 6, 10 to the minus 9. So these all change by a factor of 1,000, which is sort of what this prefix system is built on, okay? So here's one mnemonic that I came up with for this. It's maybe not the best. Kangaroo mommies carry marsupial minions nicely. There's another one that you've probably seen that's King Henry died by drinking chocolate milk, and then I added on most nights. Okay, so the one on the right is this mnemonic catches more, right? So there's kilo, hecta, deca, then the base, and then deci, centi, milli, micro, nano. And this has just kilo, and then this is just meant to be the base, the mommies. And then this would be centi, milli, micro, nano. Okay, so however you need to remember these, it's just it's really important to remember that this is 10 to the third, this is 10 to the 0 or just 1. This is 10 to the minus 2, this is 10 to the minus 3, this is 10 to the minus 4, and this is, 10 to the minus 6. Hello, come on, Mr. Ryan. And this is 10 to the minus 9. All right, so it's important to keep those prefixes in mind. All right, now one of the things that we can do with units, we have our base units, but we can also take those base units and combine them to get derived units. So examples of derived units are like area and volume and density, where area is like length times width, which means length has the base unit meters, and width has the base unit meters, which means a meter times a meter is a meter squared, okay, or a square meter. Volume would be a meter cubed, which again we won't use a whole lot. We'll use centimeters cubed a lot, we'll use milliliters, and we'll use liters. Density, we'll talk about this chapter, kilograms per meters cubed, which again we won't use a whole lot. We'll use grams per centimeters cubed, and these aren't equal, sorry, grams per centimeters cubed or grams per milliliter. That's what we're going to use more often. But you can derive the base units, or you can derive the units of anything really from the base units, okay? So I may give you something like force, which is mass times meters per seconds, or sorry, not meters, mass times length over time, and the time gets squared. So mass has the unit kilograms, length has the unit meters, and time has the unit seconds, so this is seconds squared. So kilograms times meters per second squared. So that would be the derived unit of force. So I could ask you to derive things based on that. And that's really it for our sort of intro to units.